Hello everyone, I hope everyone's having a great day so far. Today I'll be explaining why this upcoming winter 2023-2024, will be completely different than last year's winter. Now on your screen is North America view of the 500 millibar height anomalies. So let me explain this to you real quick. Anywhere in the red area is higher than normal pressures, so you're probably under ridge and possibly even a little bit above average temperatures. And in the blue areas is troughing lower than normal than height anomalies, so you're probably a little bit cooler than average. Right now, we have a ridge in the central part of the country, so you have a trough out in the west coast, right up in here, goes up into Canada and down into the northeast. At least part of my region, the northeast, was cold last night, got down into the 20s and teens inland to the farther away you get from the coast. But as we continue on throughout the next couple days, you can see that trough moves out and a ridge builds up into the east coast. But notice you have a little bit of energy off the coast of Florida. You have a nice ridge building back up into the west, and you have a nice trough coming down into the Midwest and eventually into the Northeast. Now, as time goes on, possibly a storm will try to form and go up the East Coast right before Thanksgiving. But before that happens, well, I should say while that happens, a cold front will come down into the east, bringing once again colder than average temperatures. Now, you may be asking, this is just this week. What are you talking about winter? Well, as I get along here towards Thanksgiving, you could see, look at this. You have a ridging higher than normal temperatures heights going straight from the Arctic Circle all the way down into Baja California. What does this mean? Well, it means that if you follow the isobars, you follow it down from the Arctic Circle and all the way down into America, you could see that's our cold front and where the cold air is coming from. Last year, we really didn't have this during the winter, especially towards the end of late November. We would usually have troughing out in the west coast. Here, I'll draw it out for you. Troughing out in the west coast and then ridging out in east coast with a southeast ridge. But notice our southeast ridge is not here at this time. And believe it or not, this is a beautiful setup for a storm if it wants to come along the east coast. You have your trough coming down. If anything does form over here, it will go over here. But we'll have a 50-50 low, so it will prevent it from making it a cutter going more inland. So it would be a track off the coast with fresh, cold Arctic air, with plenty of ridging out in the west coast. And I believe this would be the overall theme this year. Because if you play it out, and if even towards the end of the run, you have continuous ridging on the west coast, and negative EPO is when you have your ridging right up by Alaska, and also your negative NAO if this were to be correct. The whole overall Arctic Circle is under pretty much ridging. You can see follow the isobars. This cold air is coming straight, and I mean straight from the Arctic Circle. And this is your overall theme. This is very important that I forgot to mention. If you have a troughing right by Hawaii, that tends to lead to troughing out on the East Coast because that allows a ridge to form on the West Coast, and that's exactly what you have right now. Now, if I get a closer view up on the Northern Hemisphere and look at all the blocking that we have here, this would 100% lead to all Arctic air coming displaced down south. And speaking of cold Arctic air, if we go to the polar vortex here on the GFS, you can notice at least on this run, it was getting attacked by our ridging that was out in the west coast due to how strong it was. Now, if I just circle it, that's where our ridging was, and we go back to the 500 millibar height anomaly, you can see that's in the general area of where that was happening. If you get ridging on both sides by Alaska and by Greenland pinching into the polar vortex, that tends to lead to disruption, getting cold Arctic air displaced towards the south. And if we go back to the polar vortex one last time and take a look at it, we can see let me just fix this for you. Towards the end of the run, it's a nice tight little ball throughout the whole most of the run. But towards the end, when you get that ridging, you can see it starts to get attacked and displaced and weakens. Now, if this happens, 100% our cold air would be disrupted towards the south, giving North America either possibly the west, but most likely in the Midwest and towards the east, cold Arctic air for Thanksgiving and into the first half. Now, in the weather world, we don't just look at one model, we like to look at numerous models. This is the European, and if you want to compare it to the GFS at the same exact time, notice it's, oh, I'm sorry, this is the 18Z that's coming out. It was 198, I believe. It is eerily similar, and that's always a good sign if you want to trust a little bit of the longer range. Notice, let me just switch this real quick and change colors so you guys can see it a little bit blue. Notice we have a ridge out in the west. Our connection from the Arctic is coming down into the United States, and we have almost a 50-50 low, and we have a ridge approaching Greenland. Now, if we switch this to the European at this time, it is almost identical. Our trough is a little bit backed up in Canada, but we still have a ridge in the same place, our 50-50 low in the same place, and our ridge on the west coast in the same place. Now, if you want to go to the Canadian, you can see the Canadian is almost in a way similar, but the pink is the Canadian and the purplish blue is the GFS in Euro. The Canadian has our low up here, our ridge is already in Greenland, and our ridge is a little bit off to the west coast, a little bit more west than the GFS in Euro, which leads the trough to come back a little bit more to the west, but overall still gets the job done getting that cold air into North America. Now, if we take a look at the ensembles at this time, let me just switch it to the 12Z and go to 198 time frame. Notice it's also in agreement with what I just said. Ridging on the west coast, troughing out in the east coast, but we could work on that NEO a little bit, which is blocking in Greenland. But notice towards the end of the run, it is getting a little bit more blockier towards Greenland. We still have our negative EPO, which is once again ridging on the west coast, mostly near Alaska, is our EPO right here. Our PNA is down here usually. Notice it's a little bit of a weaker PNA, but we still have our EPO. And once again, we do have troughing out east. If you follow our isobars, notice how it goes up on the west coast. If we take a look towards the EPS, which is the European, it has a stronger signal than the the GEFs, you could say, which is the, I'll show you. This is the EPS, which is European. The GEFs is the GFS, and the GEPS with the P at the end is the Canadian, which is not really the best model you could use. But notice our EPO is a little bit more stronger, and we do have a little bit more blockiness towards Greenland, and definitely a stronger signal for troughing out on East Coast. Overall, I really do expect this to be the overall theme this year. December, mid December, I expect a warm up, but towards the end of December, towards January and February, I truly believe this will be a great winter for the East Coast, as long as everything sticks, not changes, everything sticks together and stays the way I see it in my mind. And yeah, I hope everyone enjoyed this video. Stay tuned, and this should be a very